Okay, so today we're going to do handout 4 on the number system. Today we're going to talk about how rational numbers can be subtracted. So first we're going to refresh our process for subtracting fractions. So adding and subtracting fractions, you have to have a common denominator. The denominator is how many pieces are in a whole. And so if you're looking at a pizza, let's say, if you've got a pizza that's cut into 4 slices, those slices are pretty big. If you had another pizza that was cut into 8 slices, but it's the same size as the first pizza, but it's just cut into a bunch more slices, you can't compare a slice from the 4-slice pizza to a slice with the 8 slices of pizza. They're not the same size. So that's why you have to find a common denominator. You have to know what size pieces you're looking at to make a whole number. And so we find that common denominator before we add or subtract those numerators. So you're going to find the common denominator, you adjust the numerator and the denominator so that denominators are the same and that numerators are proportional, and then we're going to subtract, and you want to make sure that you're keeping that denominator. Remember, denominators just tell you how many pieces make a whole. Okay, then if we're looking at decimals, decimals are fractions out of hundreds. So you're going to line up your decimal. When you add and subtract, line them up. Insert any placeholders if you need to. Placeholders just mean zeros. So when subtracting, you'll use the additive inverse. Remember that additive inverse simply means a number plus its opposite equal 0. And then you're going to follow the rules for adding integers. So subtracting integers, rewrite the problem to add the opposite, and then follow the rules for adding integers. So we're going to take 7 minus 16. Keep that first number the same, change subtraction to addition, and then do the opposite of that second number. So the opposite of 16 would be negative 16. Now we follow the rules for adding integers. So let's review what those rules are. If the signs are the same, then we add and keep the sign. Okay? If the signs are different, then we subtract and take the sign of the larger absolute value. So in this one we have a positive 7 and a negative 16. Signs are different, so we find the difference. We're actually going to do some subtraction with ourselves, and 16 minus 7 would be 9. Now we look at the absolute value. Absolute value of 7 is 7. Absolute value of negative 16 is 16. So this has a greater absolute value, and that sign is negative, so our answer is also going to be a negative, so negative 9. Next problem. Change subtraction right here to addition of the opposite. So opposite of 11 is negative 11. Now follow your steps for adding, which are right here on the left. If the signs are the same, we add the numbers together and keep this sign. So we're adding 8 and 11, which makes 19. Both of these are negative, so the answer is negative 19. Okay. So keep that first number. Change subtraction to addition of the opposite, and the opposite of 12 is negative 12. Okay, our signs are the same. If they're the same, add and keep the sign. So 3 plus 12 makes 15, and the signs are negative, so the answer is negative 15. Okay, keep the first number. Now add the opposite. This time our signs are different. We've got a positive 5 and a negative 13, so we're going to find the difference. And 13 minus 5 is 8. Take the absolute values. So absolute value of 5 is 5. Absolute value of negative 13 is 13. So this negative 13 has a greater absolute value, which means our answer needs to be negative as well. Answer is negative 8. So keep that first number. Add the opposite, and the opposite of 17 is negative 17. Signs are different, find the difference. So 17 minus 3. And 17 minus 3 would be 14. Look at your absolute value. Absolute value of 3 is 3. Absolute value of negative 17 is 17. So we want to take the sign with this number, which would be a negative sign. Okay, the bottom row here makes it just a little easier because of the way it's set up. The second number every single time is already negative, and the opposite of a negative is a positive. So 2 plus 10. So we change subtraction to addition. The opposite of negative 10 is positive 10. 2 plus 10 is 12. So here's how I like to think about subtraction. Subtraction is getting rid of something. So if you think 2, get rid of negative 10. So if you're getting rid of something that's negative in your life, that's a good thing. So that's a positive thing. And so it kind of turns both of those around. 2 negatives make a positive. So 8 plus 17. And 8 plus 17 is 25. Negative 9 plus 14. This time our first number was negative, which makes the numbers different from each other, or the signs different from each other. And if they're different, we have to find the difference. So 14 minus 9 equals 5. Look at the absolute value, and the absolute value is greater with 14. 14 is positive, so that means our answer is positive 5. Okay, some separation here. Keep the first number, add the opposite. Signs are different, find the difference. 16 minus 7 would be 9. 16 has a greater absolute value, and it carries a negative sign, so our answer carries a negative sign. I think of this as in, I owe you $16, I pay you back 7, I still owe you 9. Okay, looking at this one, keep the first number. Change subtraction to addition of the opposite. So negative 15 plus 4. If you owe me $15, you pay me back 4, you're still going to owe me 11. Remember, that's just finding that difference because the signs are different. Find the difference. Take the absolute value, so the answer has a negative sign. All right, let's look at some decimals. Rewrite the problem to add the opposite. So just because we've switched to decimals doesn't mean anything's changed. It's the same process. So again, keep that first number, add the opposite. Signs are different, find the difference. 6.3 minus 4.5. Can't take 5 from 3. .3 has a greater absolute value, so our answer needs to be negative 1.8. Next, keep the first number, add the opposite. Signs are the same. If the signs are same, add them. They're both negative, so our answer is also negative. It's kind of like if you owed me $2.90 and you owe me another $1.60, how much do you owe me altogether? You would owe me $4.50. Keep the first number. Add the opposite. Signs are the same, you add them. Both of them are negative, so my answer is negative. Keep the first number. This one is just subtraction. If you notice, your first number is larger than your second number, so you can skip the add the opposite if you want to and just subtract like you would in kindergarten. So 5 minus 4, 6 minus 2, and 1 minus 1, and you have 4.1. Add the opposite. Signs are the same, they're both negative. Then you add the numbers. They're both negative, so our answer is negative. Alright. Again, on the bottom, we've got this double negative happening. We've got the subtraction and the negative. So 2.5 plus 6.5. Line up your decimals and add. 8.2 plus 1.9. Line up your decimals and add. However, this one starts with that negative. Keep it, add. Signs are opposite, they're different from each other, so let's find the difference between these values. Can't take 4 from 2, so let's borrow. This is bigger and this is negative, so it should be a negative 1.8. Keep the first number, add the opposite. Signs are different, find the difference. Lining up those decimals. Can't take 9 from 8, borrow. This is bigger, this is negative, answer is negative. Think about it. You owe me $11.80. You pay me back $2.90. You still owe me $8.90. Keep the first number. Add the opposite. Signs are different, find the difference. Line up those decimals. This is bigger, this is negative. The answer should be negative. Negative 1 1/10. Okay, so that takes care of decimals. On to the harder part. We all know we don't like dealing with fractions, but it's part of life. So the process for fractions is the same. It's just going to require more steps. This one has like denominators, so it makes it not so bad. So all of these pizzas have the same size slices, okay? So the denominators are already the same. You don't do anything with the denominators. It's only the numerators that you're really doing anything with. So let's look at this one. So we're going to rewrite it to add the opposite. So 3/5 plus a negative 4/5. Since the denominators are the same, we're looking at the numerators. The signs are different, find the difference. 4 minus 3 is 1. The denominator is 5. Negative 4 has a greater absolute value, so my answer should be a negative 1/5. Okay, add the opposite. Keep that first number the same, and then add the opposite of 1/6 would be negative 1/6. Okay, denominators are the same. Focus on your numerators. Same signs, you add them. So a negative 5, negative 1, you owe me 5, you owe me 1, you owe me 6. 6 over 6 would be the same thing as a whole, and that's a negative 1. Let's fill in this blank. Rewrite the problem to add the opposite. Negative 3/4 minus 1 1/4. Keep the first number the same. Add the opposite. Trick here, you have a mixed number. We're going to make it improper. 4 times 1 is 4, and then 4 plus 1 is 5, so this is negative 5/4. Focus on those numerators. Negative 3, negative 5. Signs are the same, so add the numbers and keep the sign, and that makes that a negative 8 on top. Keep the 4 on the bottom. So if you have 8 pieces of pizza, but the box only holds 4, how many whole boxes do you have? Basically, what's 8 divided by 4? 2. Keep that sign. Okay, so we're going to add the opposite. See if I can switch it down to a skinnier pen. Okay, so keep the first number. Add the opposite. Focus on the numerators. Signs are the same. Add them together. 9 plus 3 makes 12. So it's negative 12 over 10. This is improper. Let's make it mixed. 10 goes into 12 one whole time. There would be 2/10 left over. However, 2/10 can be simplified because both of those numbers are even. Keep the 1. 2 divided by 2 is 1. 10 divided by 2 is 5. Now let's look at our sign. Both of them were negative, so that means our answer also needs a negative. So our answer here is negative 1 1/5. I'm running out of room over there. Alright, keep the first number. Add the opposite. Signs are different, find the difference. So we're going to have to subtract these numbers. Okay, so our denominators are already the same. 1 minus 1 makes nothing. 3 minus 2 makes 1. Look at your absolute value. It's greater for 3 1/8, and it's a negative sign, so it's a negative answer. Again, 1 minus 1 was nothing. That's like nothing over 8, so that's just nothing. So we focus on the 3 minus 2, which is 1. Okay, looking at the next one. This time we've got the double negative going. We've got the subtraction of a negative. Okay, still changing it to add the opposite. Keep that first number, add the opposite. Denominators are the same, so we're going to focus on the numerators. Signs are different, find the difference. 2 minus 1 is 1. Keep the denominator. Focus on what sign we need. Well, 2 is greater, 2 is negative, answer is negative 1/3. Keep the first number. Add the opposite of negative 3/8 is positive 3/8. Signs are the same, denominators are the same. Focus on the numerator. 7 plus 3 makes 10. That's improper. 8 goes into 10 one time. 10 minus 8 would be 2. And we can simplify because 2 and 8 are divisible by 2. 2 divided by 2 is 1. 8 divided by 2 is 4. And both of our signs were positive, so our answer is positive 1 1/4. Okay, first number the same. Add the opposite of negative 1/12 is positive 1/12. Denominators are the same. Signs are the same. Focus on that numerator there. 5 and 1 make 6. Denominator stays the same, which is 12. These are divisible by 2 because they're even numbers. These are divisible by 3. And we get positive 1/2. Alright, last one and out of room, so I'm going to write it over here, okay? Keep the first number. Add the opposite. Denominators are the same. Focus on the numerators. If the signs are different, find the difference. Denominator stays the same. Bigger absolute value. It is negative. So the answer is negative 4/9. Alright. Now for the hardest one. Find a common denominator. So in these fractions, these are pizzas that are cut into different size slices. That's what the denominator represents. That bottom number represents how many pieces does it take to make a whole number. Rewrite the problem to add the opposite. And then follow those rules for adding. So we got that extra step of finding the common denominator. So I can't do anything with 6 to make it become 3, but I can multiply the 2/3 by 2 to make that 3 become a 6. So we keep the first number. 2 times 2 is 4, and 3 times 2 is 6. Okay, now we're going to add the opposite. So keep the first number. Change subtraction to addition. Opposite of 4/6 would be negative 4/6. Denominators are the same. Focus on those numerators. The signs are the same, they're both negative, so we're going to add them. -1 plus -4 is -5. Denominator stays the same, 6. Okay, I can't make 8 become 4 by multiplying, but I can make 4 become 8 by multiplying by 2. And what you do at the bottom, you got to do at the top. It's got to be proportional. So keep the first number now. 3 times 2 is 6, and 4 times 2 is 8. So here's our new problem with common denominators. Change subtraction to addition of the opposite. Denominators are the same. Focus on those numerators. Signs are different. Find the difference. So 6 minus 5 is 1. Keep that denominator. Check your absolute value for your sign. 6 is greater than 5 and 6 is negative, so it's a -1/8. Okay, a couple things going on in this one. First of all, we've got a mixed number. Second of all, we don't have like denominators. So the first thing we're going to do is make the mixed into an improper. 3 times 1 is 3, and 3 plus 2 is 5. So that's a -5/3. Now we're going to change the denominators so that they are equivalent. I would have to multiply 5/3 by 4. Five times 4, 20. 3 times 4, 12. Now our denominators are the same. We're going to add the opposite. Denominators the same. Focus on those numerators. Same signs. Add them together. 3 plus 20 is 23. Keep the denominator. This is improper. So 12 goes into 23 one time. There'd be 11 left. The denominator is still 12. So for a mixed number, 1 and 11/12, our signs were positive right here, so it's a positive answer. Alright, so again, we've got an improper, a mixed, we're going to make it improper. 2 times 1 is 2, and 2 plus 1 makes 3, so we have -3/2 minus -4/5. Common denominators. I cannot multiply to make 2, 5. I cannot multiply to make 5, 2. But I can get a common denominator. So let's see. 2, 4, 6, 8, 10, 5, 10. So if I continue to write the multiples, I can see which one I need to come to, and that's 10. So I'm going to multiply this left side by 5 and this right side by 2. Okay, so 3 times 5 is 15. 2 times 5 is 10, and it's still negative, so don't change that just yet. On the right-hand side, we've got 4 times 2 is 8, and 5 times 2 is 10, and it is also still negative. Don't change that yet. So now here's our new problem with common denominators. We're going to change this to addition of the opposite. So keep that first number. Change subtraction to addition. The opposite of 8/10 would be -8/10 would be +8/10. Denominators are the same, so focus on your numerator. The signs are different, so find the difference. And 15 minus 8 would be 7. Denominator stays the same. 15 is larger than 8, so we're going to keep its sign, which is negative. 7/10 cannot be simplified, and so that's your final answer there. So let's summarize today's lesson. So, signs are the same. We're going to add and keep the sign. Signs are different. This is in addition, by the way. Because if you don't know the addition, you can't do the subtraction. If the signs are different, you're going to subtract and keep the sign of the greater absolute value. What about subtraction? Change it to add the opposite. So, for example, a subtraction problem can be changed to adding the opposite of the second number. So, once you change it to an addition problem, you just follow those addition rules that we just said. Now, as far as fractions go, when adding or subtracting, you must have a common denominator. And then with decimals, when you're adding or subtracting, you've got to line up your decimal places. When you're completing your notes, I want to see all that work. Remember, if I write it, you write it. Good luck. Email me with questions.